Well, first of all, thank you for joining here for the presentation. The presentation is about lithium batteries. We had the smart lithium batteries, and we're moving over to the NG battery. So I would like to explain a little bit what is the difference, and well, in real life, what is the benefits that you have for that. Besides that, we're also working hard on getting more redundant features in our lithium system, because we feel also that because the systems are growing in size, that also redundancy is more becoming a topic. Uh, Here I have a microphone. Please interrupt me if you have any questions. But if you ask the questions to me, the rest of you will not hear it. So there's a microphone. So please use the microphone to give your question to me, and then I can hear it, and then so the rest also. So I leave the microphone over here. So grab it if you want, and interrupt me as much as possible. But that makes it also more reliable. Otherwise, I'm just clicking away slides, and that might not be not so exciting. What we have now is the smart lithium batteries. And smart lithium batteries are basically the batteries which are basically built with a BMS inside and outside. And how that works is basically that every cell, if you have a battery, one slide back, if you have a battery enclosure, in that battery enclosure, there are a number of cells. And each of those cells has its own specific circuit board. And that circuit board is looking at that cell where it's mounted on, and it's looking at voltage and temperature, basically everything what could potentially go wrong and could be dangerous for that cell. These cells are communicating that information to the system, because that's the huge difference between a lithium system and a lead acid system, for instance, that all the cells need to be monitored because there is a potential danger financially, but also the danger side, that things go wrong if things are not managed well. So basically, all the lithium batteries are able to communicate with the charging source and also with the inverter source. So in order to have the battery communicate with the system, you need something to connect it to. And that's called the BMS externally. So you have an external BMS and an internal BMS. Later on, I will explain a little bit more about BMSs, but in any case, you need the BMS either internal or external. Well, this lithium battery, what we have changed is that communication between these cells, so the circuit boards on these cells, are not communicating analog anymore, but digital. And digital means that you can much faster read out all the information of each cell, and also are able to be easier in updating and also easier in monitoring, because from one point you can get all the information from all the cells in the system. You have to realize if you have 3 cells with an analog communication protocol and you want to see what's happening, you have to connect to one and then monitor that, and then you have to connect to the other one and monitor the third. So it takes more time, and also you forget, well, which one did I look at actually? Because you can't see from the outside where the connection is made of. But with digital, that's easy, because instead of connecting to the battery each time when you want to see something, you can connect to the BMS. So the smart lithium batteries have a Bluetooth built in, so you can have your tablet or your iPhone or whatever connected to the battery. And with the newer batteries, that's gone. But that Bluetooth, instead of in the batteries, is now moved to the BMS. That means in the BMS, all the batteries are connected to. So if you ask the BMS, hey, if everything is going well, then automatically that BMS can scan all the cells, can see all the values of each cell individually, and can also determine what to do. The nice thing is also that instead of having an alarm on an analog system, but having the data from a digital system, you can control things like balancing much better, because you know exactly what you're doing and what you should do to improve the situation. With analog, it's more on-off. It's okay or it's not okay. And with digital, you can say, okay, now I'm in this phase of the process, so I can change things over time. Well, the enclosure themselves did not change. It's more what's inside which is different. And here you can see the old way of doing it is the digital communication from the BMS to the battery. One other negative part of the heavy analog communication between the batteries is that it's connected. It's connected to the voltage which is between the units, and on that voltage there is that analog signal. That means the more batteries you connect in the system, the lower that voltage will be. So the more losses you have on your signal. So there is the maximum amount of batteries that you can connect in the system, because at a certain moment that signal is so low, you cannot distinguish an alarm or a good state anymore. So it means in an analog control system, the number of batteries is always much smaller than on a digital connected system. Yeah. So with the NG, like I said, then you have all the communication digitally brought to your BMS, and that means that signal can be broadcasted over much more batteries. So in this case, it's about 50 batteries each. So given the fact that the largest battery we have is a 24300, 700 kilowatts. So you have 50 times 7.5 kilowatts. So that's already a huge system to your head. Of course, if you would make a system like that, you would choose, I guess, more than one BMS so that you have multiple banks and make it a redundant system. But more about that. Are there questions so far? Versus everything okay? Everything okay? Yeah. Oh. Yeah, you have a question. Oh, there. We have to switch it on, I guess. Yes. Yeah. It's actually very simple. You can see on the battery, I don't have the picture. There are two cables. And basically what is done is that on one side of that cable, we put on every wire, we put 5 volts, and we look at the other side, what comes out. And each cable which runs through these circuit boards and through all these batteries, goes through these circuit boards on the cells. If one of them has an alarm, let's say voltage, and one of these wires in that cable will lose the 5 volt transfer. So that means we look at if all the 5 volts are present on all the wires, well, then it's okay. If one is missing, well, it's either low voltage, high voltage, temperature, or whatever. So it's very simply cutting off or being there. Steve. Correct. Correct. But that's the other one. If you look at the digital one, that one has also a 3-wire communication, but that's digital. So then all the cells report on each level exactly what the state is. So then you have the exact voltage of a cell. You have therefore also the imbalance between the cells. You have the temperature. Basically everything you want to know is then digitally broadcast. So then you have all the data. Yeah. And it comes from one point. That means if there is an update or you want to change settings, so you want to have the discharge flow changed or whatever, you only have to tell the BMS that, hey, I want to have this setting now across all my batteries. And as soon as you press the button, that setting goes to all the batteries. So the benefit of that is that always the firmware from BMS and battery will match because, well, that they're just copied on each other. And all the settings are also distributed within a second in all your batteries which you have connected. And that's also a huge benefit above the analog communication because then you have to have the settings per battery. So it makes life much easier, I would say. Well, we added the mounting bracket to it because a lot of times there were issues how to secure a battery into a system. This is not the 100% ideal. If you have a really mobile situation with lots of shocks, I would still advise you to use a strap or something. But for a lot of applications, this is also a good thing to have extra. Well, the BMSs themselves, they look exactly the same. So we have the small BMS, you have a V-bus BMS or the Lynx BMS. But that's not true, of course, because internally they're different. The other ones communicated analog, and the newer ones communicate digitally. That means you cannot interact these two. So you cannot use an NG BMS on a not NG batteries because one is expecting a digital signal and the other one is expecting an analog system. So the BMS and the batteries need to be from the same family. That's either analog or it's digital. If you have an analog system, so the Lynx smart system, then you could add another BMS parallels on the per set to extend your system. So if you say, well, I have already 20 kilowatt hours on smart lithium batteries, but you want to go for a bigger system, then you can add an NG BMS with NG batteries on top of them. And these BMSs will then work as one. So you can extend your system with different kinds of units, but you cannot integrate them with the same units in the same bank. Yeah? This is a small BMS. The small BMS is often used if you have something which is able to communicate and able to switch. So this BMS has a big contactor in itself. That means if something would go wrong, it can disconnect itself from the load, so from the charger source. This one doesn't have that, but it has the signals to, well, relay that signal forward to a contactor or maybe to an inverter which you have to switch off or whatever. So this one is mostly used for the smaller systems where only a few batteries are used. They say, well, hey, I don't need a very large contactor. I can do it also in a different way with the battery protect or whatever. Yeah. I already told you a little bit about the ability to have BMSs connected to each other. And that's also what I said in the beginning. That's part of redundancy. Redundancy becomes more and more a topic on the systems that we build. That can be propulsion, that can be some industrial application for mining or whatever. That it's essential that the power in the banks, in battery banks, always are available also that if something goes wrong. Well, redundancy means that have extra devices in your system. So it's not that one unit can do more than one thing. How redundancy means you plant extra components in your system and therefore you can rely still on the system if one of these components should fail for whatever reason. So redundant system always is more expensive than the non-redundant system because, well, you're building your own security, so to say. With redundancy, well, I think a lot of systems would benefit, especially, like I said, in a propulsion. You don't want to be stopped in the middle of nowhere because, well, the lithium decided to stop. That's also the huge difference between lead-acid batteries and lithium batteries. If you have a lead-acid battery, you can feel when they're running out. Things get a little bit slower or the lights dim a little bit, but it still continues to go. With the lithium, it's just like this, and then it just stops because there is a mechanism at the BMS that's decide how long the system should be discharged. So if something goes wrong on the cell and the BMS says, well, this is it, then you're in the dark. And that's why, especially for the larger systems, it makes sense to have one or more redundant systems built in, especially when you're depending on it, like in this case, mining for industrial systems. Any questions so far? Yes, there is. No? So, well, basically, you can parallel whatever you want. You can also parallel different types of BMSs to each other. And also the capacity per bank may be different. So you can well have a 20 kilowatt hour bank in parallel with a 50 kilowatt hour bank that you would like to. The system itself makes a virtual BMS. That means the number of BMSs you connect are being read out by the system, and the system says, okay, I see 3 BMSs, and I create a virtual BMS, and a virtual BMS is also shown on the overview, and on there you see the state of charge, you can see the amps, you can see the voltage, whatever, and that's the combined information from all the connected BMSs. If one of the BMSs would fail or would just simply switch off, then that goes out of the equation, and you see only the active BMS is still running. That means the information that you see is the actual information that actually is there. So the state of charge which is shown is the state of charge what you have. If there is a situation changing, so a battery bank which is switched off can be switched on again because, well, it's being charged or whatever, then automatically the virtual BMS recalculates the situation and gives you the actual numbers again. The system works so redundant that if something would happen, somebody would pull a cable or whatever would happen, and the system would run on its own. The system would run on its own until it's not able to run anymore. That means it doesn't need the communication to run. You have maybe seen other redundant systems, but these redundant systems need boxes to check if, well, the system is on or off or whatever. But this system is so robust that if something goes wrong, it keeps on working by itself until really a cell or whatever would decide that it will stop. But in the real world, if you would cut a cable or something else worse would happen, then you still would have power on your common bus bar. And the system does that automatically. Any questions so far? Yeah. You have a question? Yes. It's here. This. This. Sorry, Mom. Yeah. Yeah, well, to be honest, this is a redundant system on the battery side. This is not a redundant system on the inverter side because then you need a double amount of inverters as well. Correct. Yes. Yes. It's actually a very good question. What we have at the moment is that each unit, or units which are in 3-phase or in parallel, they have a configuration file. And configuration file you make when you parallel units. So the system knows, well, that serial number is phase 1, that serial number is phase 2, and so on. What you can do now is that you can copy that file from the server or whatever, and then you can reload a different file. So if you would make a file for 1 unit standalone, 1 unit in parallel, or 1 unit in 3-phase, you can choose later on to change that file into your system. That means if one of the units would stop working for whatever reason, you can select a different setting without having to program it, and you just upload that settings file into the system, and the units which are still able to run are running then. Yeah, that also means if you're swapping a unit, you don't have to reconfigure that unit completely as it was. You just reload the old setting from the situation before, and then the system keeps on running as it was. Yeah, that answers your question? Okay. Yeah, well, like I said, this is how you can create redundancy on parallel battery banks. It's quite easy to do. It's actually, for a lot of people, so surprisingly easy. It's just plugging in. It sees it, it detects it, it makes the virtual BMS, and from there on, it's just a redundant system. So it's very easy, and it's also very, I would say, bulletproof. If something would happen to a battery, it waits until the window of opportunity is there to re-engage again, and it makes the system think for you. Also, the balancing, all the other things are being erased in a digital way, and that's a really nice and secure way to have redundancy built in. I think, there's another picture of a system by itself. What we have also, and maybe you've seen it last year, is the Class T power-in fuses. Normally we have the links distributor, and the links distributor, you have the A&L fuse in or the mega fuses in. But for larger lithium banks, the short circuit current can be very high. It can be so high that the fuses are not able to cut that in case of a short circuit. And when you have a short circuit on a lithium battery, you're speaking about thousands and thousands of amps. Well, a mega fuse might be able to stop that, but most likely that mega fuse will just explode because the current is so high that that fuse is not built for that. In order to be protected against these kind of extreme situations, you can use Class T fuses. Class T fuses, well, they go up to 20,000 amps on short circuit current. That means if you have the larger battery banks installed in systems, then you have to use these kind of fuses, which are, irritatingly expensive, I admit right away, because you have to pay serious money for these fuses. But you have to do that because otherwise you're not able to cut off high short circuit currents. In the Class T power-in, there are 2 of these fuses, so you can have 2 strings of batteries protected there. With lithium batteries, it's always important that each string is fused. So if you have a 12-volt system, then every battery is being fused. If you have a 24-volt system, you would have 12-volt batteries in the series. Then each string of those 2 would be fused. That also makes it logical to have big, lower voltage batteries in series, because then the number of fuses are being reduced. The more units you have in parallel, the more capacity of fuse you would install. But a Class T fuse Class in power-in has 2 of these inlets. That means it can handle 2 strings, and every more strings you need more Class T power-in is connected to it. Yeah. Pass. Anything can happen. You can have something in the wiring, something can go wrong in the bus bar, that something happens there. You could also have that one battery is failing, and the other battery is trying to feed that battery. So you have the energy from one battery going to the other battery. So you can have a lot of things. And of course, hopefully you will never use this fuse, because this situation will never happen. But if it happens, if you have something with your wiring or with the unit or whatever, and you have full short circuit, you'll be better off with these kind of fuses to stop the energy flow than if you would have a mega fuse or an A&L fuse. It is an extreme situation, but it can happen. And that's basically always true in technology. If something can happen, well, there is only a matter of time, and it will happen. So it's sort of a security that you build in a new system. Any more questions? No? Think? I have this is the inside, but some of course it is. Well, that was the last slide. Thank you very much for your attention. If there are any questions, there are a lot of people here able to answer questions that you have, and also perhaps show you around what new models we have and what new stock on software is available now. So thank you very much, and I hope to see you in another time.